In page number 23, you can see a triangle and you can read this heading as isosceles triangles. And isosceles triangle, what do you mean by isosceles triangle? If two sides are equal, when we consider a triangle, and we can see if two sides are equal, we can read it as, or we can call it as an isosceles triangle. If all sides are equal, if all three sides are equal, we can call it as equilateral triangle. And now we discussed the isosceles triangle. What is the property of an isosceles triangle? And the basic property, primary property is that two sides are equal. And also another property is existing there, that is the base angles are equal, or angle opposite to equal sides, angle opposite to these equal sides are equal, or we can see these angles are base angles, and we can read, or we can call all the base angles of an isosceles triangles are equal. Then from this property, what is this property? The sides are equal, and we want to reach to this property. What is this property? The angles, base angles are equal. And now we put some arguments, and from this property we want to reach, or we want to prove the angles, base angles are equal. How you prove? By the sides are equal, and how you reach into the angles are equal. That is, we take a extra line from C to M, where M is the midpoint of AB. We want to prove angle A is equal to angle B. For that, we have the idea angle this side and this sides are equal. And for extra idea making, we can construct a line from C to M, and M is the midpoint of AB. Then we can see this side is equal to this side. What is the reason? M is the midpoint of AB. Now you can see AC is equal to this side, AC of this left triangle is equal to BC of this right triangle. Therefore, these two sides are equal. These two sides are equal, that is given. And AM is equal to, it is simple, AM is equal to what? BM. What is the reason? We construct CM like M is the midpoint of AB. What about the third side? That is, third side CM is common. Therefore, we can say CM is equal to CM. That is, all sides of first triangle, yes, are equal to all sides of second triangle. These two left side triangle, when we considering these two left triangle, all sides of this left triangle is equal to all sides of this right triangle. Therefore, all sides are equal. All sides are equal implies what? These two triangles are equal. These two triangles are equal implies what? Side angle opposite to equal sides are equal. Easily we can see this side in this left triangle is equal to this side in the right triangle. Therefore, angle opposed to here is angle A is equal to angle opposed to here in this triangle is angle B. That is what we say, angle A is equal to angle B. Therefore, from CA is equal to CB, or from sides are equal, we get what? Angle A is equal to angle B. That is, the base angles are equal. That is, we apply the congruency of triangle in here. Here we apply the equality of two triangles using sides are equal implies angles are equal. Now in page number 24, we discuss the reverse of this theorem. That is, what is the statement says? If two angles of a triangle are equal, are the sides opposite to them also equal? Here we have angle A is equal to angle B. And the reverse of this theorem, angle A is equal to angle B is given. That is, the base angles are equal. And from that we want to prove what? CA is equal to what? CB. The sides are equal using our arguments. And now we construct for this argument a new triangle here. And you can see an extra line which drawn from C to the point P. And here the point is marked as this angle is 90 degree. And this is a perpendicular from C to the side AB. And now P is not a midpoint. In the later section, we says M is the midpoint of AB, and here P is not a midpoint, but we drawing like that what this angle make 90 degree. Therefore, we consider the left triangle and the right triangle. Which are the information you have given? The information you have given is angle A is equal to angle B. That is angle A is equal to what? Angle B. And next one is this angle is this angle. That is angle P in this first triangle is equal to angle P in first triangle is equal to angle P in second triangle, because each angle is what? 90 degree. And now another information you can obtain, what is the third angle will be also equal. This angle will be also equal. What is the reason? Angle C, angle ACP, angle ACP is equal to angle BCP, angle BCP. What is the reason? The total angle is 180. Total angle is 180. If two angles are equal, to another triangle, then third angle must be equal, because the total sum is what? 180. And now you get it. Angle P is equal to angle P. Angle P is equal to angle P, and angle ACP is equal to BCP. This angle is this angle, and this angle, this angle. And you can take this is a common side. And CP in this triangle, in first triangle CP and in second triangle CP are same, because CP is common. Therefore, you can see one side and two angle. That is by the property ASA. Two angle and included side, two angle and included side, or one side at the end angle. Using the property ASA, you can say what is these two triangles are equal. If these two triangles are equal, you can see angle side opposed to 90 degree in this triangle is AC. AC is equal to side opposed to 90 degree in this triangle is CB. That is AC is equal to CB. And here we prove the reverse of the theorem, but we apply in the last section yes idea, and here we apply ASA idea, and another idea we have SAS idea, and three statements you want to recall in these problems. And here we discuss what is the measure of an angle in an equilateral triangle. In an equilateral triangle, you know all sides are 4 centimeter, and this is not one equilateral. So many equilateral triangles are there. Equilateral triangle means what? All sides are equal. All sides are equal. And another equilateral triangle, you can see what? All sides are equal. And so many equilateral triangles are there. And but total angle sum is 180 in this big triangle and this small triangle. Total angle sum is what? 180. And 180 want to divide into angle, three equal angles. Therefore, each angle is what? 60 degree. And in any equilateral triangle, all angles are what? 60 degree. This angle is 60, and this angle is also 60, and this angle is 60, and each angle in equilateral triangle is 60, and angles are equal not implies. In the first section we say that if all angles are equal not implies what? Triangles are equal. In these four triangles, you know, all angles are equal, but triangles are not equal and sides are not equal. Okay, you can see some problems in page number 26. You want to take your textbook and you want to do the problems at first, and then you want to copy that problems into your notebook. Then only you can improve your mathematical thinking. And after that, if you have any doubt, then only you want to see this video. Okay, first of all, you want to do the problems as your own thoughts. Okay, and some isosceles triangles are drawn below. In each one, angle is given, find their angles. You want to use only two ideas here, that is angle sum property of a triangle. What is angle sum property of a triangle? In any triangle, if it is isosceles or equilateral or any type of triangle, the angle sum property is the total angle is what? 180. And here another property you can see, the isosceles triangle, the base angles are equal. And another property of a triangle is that the equal triangle, all angles are 60 degree. And three ideas you want to apply in the coming problems. Therefore, you want to do the problem at first. Okay. Then your own thinking, you want to use your caliber in these problems. And after that, you want to see this video. Okay. Some isosceles triangles are drawn below. In each, one angle is given. Find the other angles. And you can see an isosceles triangle here. And you can see these two sides are equal. Therefore, this angle is 30 degree. Very good. This angle is what? 30 degree. You can say what is this angle? This angle is 30 degree. And angle sum property says what? Total is 180. Then what happened? 30, 30, 60. And 60, the remaining of 60. Minus and 180 minus 60 is what? 120. And 120 plus 30, 150 plus 30 is 180. And here 40, 40. And this is isosceles triangle. These two sides are equal. Then angle opposite this base angle. Opposite sides in the opposite angles are equal എന്ന് പറയുക. അല്ലാതെ ഇത് 40 ആണെങ്കിൽ ഇത് 40 എന്ന് എഴുതാനുള്ള പ്രശ്നം ഉണ്ടാവരുത്. ഇത് 40 ആണെങ്കിൽ ഇത് 40 എന്ന് എഴുതി കഴിഞ്ഞാൽ അത് തെറ്റിപ്പോയി. ഇത് 40 അറിയുമ്പോൾ ഇത് 40 ആയാലും തെറ്റിപ്പോയി. ആ രണ്ട് മിസ്റ്റേക്ക് അവിടെ വരിക. And this angle opposed to these angles are equal. These two angles are equal. And 40 is here over. Then 180 minus 40. That is 180 minus 40 is what? 140. And 140 will be equally divided into these two sides. 140 by 2. That is 70 degree here and 70 degree here. Both these angles are 70 degree. And now you can see this problem. And can you identify this isosceles triangle? And these two sides are equal. On looking, we can see these two sides are equal. And this 20, this 20, not this 20. This 20 is over. Then remaining is 160. And this 160. 20 is after 180. It is remaining 160. And 160 is equally partitioned to here. Therefore, you get what? 80 and 80. And now, there is a triangle with one angle is 100 degree. And these two sides are equal. On looking, not these two sides. This is the largest side. These two sides are equal. And 100 is here over. The remaining is 80. And 80 you want to put here 40 and 40. 100 is here over. Remaining is 80 for 180. Then 40 here and 40 here. Then that angle is over. Then next question. One of an isosceles triangle angle is 90 degree. What is the other two angles? One angle of an isosceles triangle is 90 degree. What happened? One angle, an isosceles triangle is 90 degree. And you see this angle is 90 degree. Then this angle is 90 degree. Remaining angle is what? Total 180. Remaining is what? Remain 90. And 90 is equally divided here. What you get? 45 and 45. Both two angles are 45 and 45. Therefore, it is over. One angle of an isosceles triangle is 60 degree. What are the other two angles? One angle of an isosceles triangle is 60 degree. One angle of an isosceles triangle is 60 degree. What are other two angles? One angle of an isosceles triangle is 60 degree. What is the answer? You say one angle is 60 degree. This angle is 60 degree. What is the remaining? 120 degree. And 120 degree divided by remaining equally divided into two angles. That is 60 and 60. Therefore, this is also. And next question, fourth question. In figure below, O is the center of the circle and AB are points on the circle. Compute angle A and angle B. Very simple question. In the figure below, O is the center of the circle and A and B are points on the circle. You know OAB. OAB is a triangle. And what about OA and OB? OA and OB are radius. O is a center, therefore OA and OB are radius. And all radius are equal. All radius, so many radius you can draw here. All radius are what? Equal. Therefore, these two sides are equal. These two sides are equal in place. This is the what? Isosceles triangle. And one angle is 60. Remaining angle total is 120. And you want 120 part here. That is 60 and 60. Therefore, that is simple question. Next question. In the figure below, O is the center of the circle and ABC are points on the circle. Then what are the angles of triangle ABC? You want to find triangles of ABC. Angles of triangle ABC. This angle is 120. This angle is 120. And here what happened? This is a triangle. Total 180. 120 is over. Remaining 60. Remaining 60. 60. Then 30 is here. And here is also what? 30. And here total 120. Same triangle is here. All sides. There is no need of calculation. These two triangles, what happened? These two triangles, what happened? One side and one side are equal. These two sides are equal to those two sides. And 120 is 120. Therefore, there is no calculation using SAS. Two sides and include triangle. Two sides and include triangle. You can say these two triangles are congruent. These two triangles are congruent means what? Here also 30 degree, here also 30 degree. There is no calculation. And this angle, you know, this angle is 120, total 360. Around one point, you can see total 360 degree. Therefore, this side is also 120 degree. This 120 degree means what? This side gives also 30 and this side gives also 30. Then angles in this triangle is 60 degree here. Here also you can see 60 degree. Here also you can see 60 degree. And what happened? The inner triangles are isosceles triangle, but the total outer triangle ABC is a equilateral triangle. The inner triangle, the small triangles are isosceles triangle because all sides are radius. All sides are radius. That is isosceles triangle. But the outer triangle, the bigger triangle is an equilateral triangle. That is the idea here. Okay. And now we discuss how we draw the perpendicular bisector of a line using the property of isosceles triangle. And here a line is given to V. And now we want to draw the perpendicular bisector of this line. Then first of all, we take this point, the end point, and take some distance more than the half of this, the length. ഈ ലെങ്ത്തിൻ്റെ ഹാഫിനേക്കാൾ വലിയ ഒരു ലെങ്ത്ത് നമ്മൾ സെലക്ട് ചെയ്യുക. അത് സെലക്ട് ചെയ്തതിന് ശേഷം ഫസ്റ്റ് ഓഫ് ഓൾ വി ഡ്രോ എ ആർക്ക് ഹിയർ. ഇവിടെ നമ്മൾ വലുതാക്കിയിട്ട് ഒരു ആർക്ക് നമ്മളിവിടെ കൺസ്ട്രക്ട് ചെയ്യുന്നു. അതേപോലെ തന്നെ നമ്മൾ ഇതിൻ്റെ നെക്സ്റ്റ് സൈഡിൽ, ദെൻ അപ്പർ സൈഡിൽ ഒരു ആർക്ക് കൺസ്ട്രക്ട് ചെയ്യുന്നു. നൗ വി ടേക്ക് ദിസ് പോയിന്റ് ആൻഡ് അഗെയിൻ വി കംപ്ലീറ്റ്. Here we also construct again an arc here. I want to intersect these two arcs in this point, and you can extend this arc like this, and now we can complete this arc lies here. Then we can draw one intersection point here. Here we get one point, and also in the upper part you get one intersection point. And now we can join these 2 points of intersection. We can join these 2 points of intersection by using an scale. You get 2 points of intersection of the arc here, and you can join the point of intersection here. You can join the point of intersection. You can join point of intersection using these 2 points of intersection. You get the perpendicular bisector of a line here. And this perpendicular bisector means this is the midpoint of the line, and this is also, this angle is 90 degree. Then for any line using the property of isosceles triangle, we can draw a perpendicular bisector like this. And next there is a question you can see. Draw a line of 6.5 centimeter long and draw its perpendicular bisector. You want to draw a line of 6.5 centimeter long. How you draw? You can use a scale and take the distance is 6.5 centimeter. There is no need of any straight line, but you can draw from the point 0. You can draw a line that is 6.5. From the point 6.5, you stop this line, and now we have a line like 6.5. There is no need of a straight line. You can draw. നമുക്ക് ഒരു ചെരിഞ്ഞ ലൈനൊക്കെ വരയ്ക്കാം. അതിങ്ങനെ സ്ട്രെയിറ്റ് ആയിട്ട് തന്നെ വരയ്ക്കണം എന്ന് പറയുന്നില്ല. Then what is the we want to prepare a perpendicular bisector. Then first of all, you please take this end point and take a distance more than the half of the length of this line, and you please construct an arc here, and you please construct an arc here also. Then you take the next end point here, and you can complete an arc like here. There is a point of intersection here, and you can construct an intersection here also. Then you can take a point of intersection of 2 arc, and by joining these 2 intersection point, you get the required perpendicular bisector. Correctly, you want to draw the intersection point, then you get the 6 point, the intersection point of these two lines in the perpendicular bisector. You get the perpendicular bisector there. And next question, draw a square each side 3.75 centimeter long. First of all, we can't draw a 3.75 centimeter in this page using an scale, but we can draw the double of 3.75, and the double of 3.75 we have already drawn, that is the line 6.5 centimeter in the previous lesson. We draw a line 3.75, the double of 3.75 is equal to 6.5. Now this total length is what? This length, total length is 6.5 centimeter, and we prepare the half of 6.5, that is equal to this length. You can see this length is 3.75 and this length is 3.75. Then how you prepare a square of 3.575 centimeter side? First of all, you want to take this 3.75 centimeter side, and now we mark one point in here. You can mark one point here using this length, that is 3.75. You can mark here a point 3.75, and now you can put this position here, and again you can mark a length 3.75 like this, and now you can mark again 3.75 from this position, and you can mark here, that is 3.75, and you get now the 4 points of this square. And now you can draw the required square like this. Mark these 2 points. You can draw, you can join this using here. You can join the fourth side of the square like this. Then you get here a square ABCD, and each length is 3.75. The total length is 6.5 centimeter, and each this length is what? 3.75 centimeter. And next we discuss how we construct the angle bisector. Angle bisector എങ്ങനെ വരയ്ക്കാം എന്നുള്ളതാണ് നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത്. അതിന് ഫസ്റ്റ് ഓഫ് ഓൾ വി പുട്ട് ദിസ് പോയിന്റ് ഇൻ ഹിയർ. ഈ ഷാർപ്പ് പോയിന്റ് ഇവിടെ ടച്ച് ചെയ്യുക. നമ്മൾ എന്ത് ചെയ്യുന്നു? ഒരു ലൈന് വരയ്ക്കുന്ന പോലെ, നമ്മൾ നേരത്തെ പറഞ്ഞ പോലെ ഒരു ആർക്ക് ഈ രണ്ട് എഡ്ജിനെയും ടച്ച് ചെയ്യുന്ന പോലെ ഒരു ആർക്ക് വരയ്ക്കുക. യു വാണ്ട് ടു കൺസ്ട്രക്ട് ഫസ്റ്റ് ഓഫ് ഓൾ വൺ ആർക്ക് ഹിയർ. ഈ ആർക്ക് ഇതിനെ ടച്ച് ചെയ്യുന്ന രൂപത്തിൽ കൺസ്ട്രക്ട് ചെയ്യുക. എന്നിട്ട് നമ്മൾ എന്ത് ചെയ്യണം? ഈ ആർക്കിനെ ഇതേപോലെ നമ്മൾ പെർപെൻഡിക്കുലർ ബൈസെക്ടർ വരയ്ക്കുമ്പോൾ ഈ ആർക്കിൻ്റെ പകുതിയിലധികം ലെങ്ത് എടുക്കുക. ഈ എടുത്ത ലെങ്ത് പകുതിയിലധികം ആയതുകൊണ്ടാണ് ഇത് മാറ്റാത്തത്. ഈ ആർക്കിൻ്റെ പകുതിയിലധികം ലെങ്ത് എടുത്തിട്ട് വി വാണ്ട് ടു ജസ്റ്റ് കൺസ്ട്രക്ട് എ ബിഗ് ആർക്ക് ഹിയർ. ആദ്യം വരയ്ക്കുന്ന ആർക്ക് എപ്പോഴും നീട്ടി വരയ്ക്കുക. പിന്നെ അതേപോലെ നമ്മൾ ഈ പോയിൻ്റ് നമ്മൾ എവിടെ ടച്ച് ചെയ്യുന്നു? ഇവിടെ ടച്ച് ചെയ്തതിന് ശേഷം ഈ ആർക്ക് ഇൻ്റർസെക്റ്റ് ചെയ്യുക. ഇൻ്റർസെക്റ്റ് ചെയ്യുമ്പോൾ യു ഗെറ്റ് എ പോയിൻ്റ് ഹിയർ. ഒരു ഇൻ്റർസെക്റ്റിംഗ് പോയിൻ്റ് കിട്ടും. ഇൻ്റർസെക്റ്റിംഗ് പോയിൻ്റ് കിട്ടിക്കഴിഞ്ഞാൽ നമ്മൾ നേരത്തെ പറഞ്ഞ പോലെ യു ക്യാൻ കൺസ്ട്രക്ട് എ ലൈൻ യൂസിങ് എ സ്കെയിൽ. ഈ ഇൻ്റർസെക്റ്റിംഗ് പോയിൻറ്റും ഈ വെർട്ടക്സും യോജിപ്പിച്ചുകൊണ്ട് യു ക്യാൻ കൺസ്ട്രക്ട് എ ലൈൻ. then you get the angle bisector, the required angle bisector. ഇപ്പോൾ നമുക്ക് ഈ required angle bisector കിട്ടും, and you can measure these two angles are equal. ഈ രണ്ട് ആംഗിളും ഈക്വൽ ആയിരിക്കും. This line bisect this angle as two angles which equal measure. It is the bisector, angle bisector of this angle.